Good morning. This is in continuation with the previous session. Now just look at. So one more point, one more time, just we will discuss energy and power signals. This is a very important concept. That's why just, even though it was completed in the previous session, just here I am making my best to give you another repeat. Now this is for energy signals. A signal is said to be energy signal if energy is less than infinity and power is finite. Finite, not finite, I have almost all zero. A signal is said to be power signal. In this way, energy is infinity, but here power is finite. Now just look at. These two are very much important comparisons. A signal is said to be energy signal if the energy is less than infinity. In energy signals, power is always zero. Now, a signal is said to be power signal if energy is infinity. In power signal, power is finite. Now, there is another concept, that is average power. How to calculate average power? Before calculating average power, just we have to calculate first energy. How to calculate energy? Between the given time interval, you take whatever the signal is given, you take and make square. Integrate with respect to dt and take the limit t tends to infinity. Just look at. This is energy formula. Now, average power. The name itself is average. Average power. Average power means what? Write the energy and dividing by its width of the signal. That is equal to, that is what? The same formula. Limit t tends to infinity. Here just look at minus t by 2 to t by 2. Same squaring of the signal with respect to dt, but here you have to write 1 by t. Whenever you divide the width of the signal by the energy, the parts it gives is called average power. So energy signals do not have power. Power is zero. So power is finite for average power. In power signals, energy is infinity. That's why we are calculating power. Now just look at, average power will be obtained by dividing the formula of the energy by the width of the signal. Look at, this is an important concept. Okay. Now this is for your understanding purpose only, just I repeated. Now next topic is orthogonality. Orthogonality of complex signals. Orthogonality of complex signals. You can expect a 2 marks question on this one. Orthogonality of complex signals. Simple topic. Orthogonality of complex signals. So here the signals are not ordinary signals. Signals are what? Complex signals. Complex signals means what? They contain imaginary number also. In maths you write I, in electronics you write J, both are same. We write 3 of I, in electrons they write J3 like that, or 3J, anything. This is the difference between these two. Okay. Now, complex signals, let. How we are writing, look at. Let x1 of t and x2 of t be two complex signals. Two complex signals. These are two complex signals. What do you mean by complex signal? See, in mathematics, if AIB is a number, its complex conjugate is A minus IB. If C minus ID is a complex number, its complex conjugate is C plus ID. So whatever the symbol it has, complex conjugate means opposite symbol. In place of plus you write minus, in place of minus you write plus. But A, IB never changes. Okay? Now, this is never changes. Now just look at. So now If these two are complex numbers, then these two signals are said to be orthogonal. These two are said to be orthogonal over a time period t1 t2. When they will be orthogonal, that is integral over t1 t2. Take the first complex signal, multiply with the complex conjugate of second signal, dt should be 0. Or the same should be taken, same t1 t2, in place of x1t you can take x2 of t also. Now here multiply with complex conjugate of x1t, dt equal to 0. Now just look at over the time period t1 t2, x1t x2 are complex. Take any one signal and multiply with the complex conjugate of second signal, or take x2 of t first and multiply with complex conjugate of the first signal. Look at that, bar implies complex conjugate, 1 complex conjugate of 2 or 2 complex conjugate of 1, but output should be, both should be 0. If the output both we got 0, if we get 0, then these two complex signals are said to be orthogonal. That means what? These two complex signals are said to be orthogonal if you multiply these two in this way and integrate between the given time width over time period with respect to the time variability. If you get the output is 0, result is 0, whenever you get result is 0, the signals are said to be orthogonal. These two complex signals are said to be orthogonal signals, orthogonality of complex signals. Same principle. Two signals are said to be orthogonal. If you conjugate, you remove the conjugate, then you have to remove the word complex. If you put the bar, you have to keep the word complex. That is the only difference. Only bar difference is the bar. But take first signal, complex conjugate of second signal. Take second signal, complex conjugate of first signal. That is the difference. This is the orthogonality of complex signals of orthogonality of complex signals. This is the principle. Now just we are starting the important concept of Fourier series. Fourier series, very important concept. In Osmania University, they are giving direct one question on Fourier series for 14 marks. Direct question. If they give the small question, they will make it the 10 marks, they split into the plus 4 mark question. Understanding? Anyway, in most of the cases, what we seen is that one direct question on the Fourier series for direct 14 marks. So students have to concentrate more on this one. Very easy, very important also. Now just look at it. Now, what is the purpose of studying Fourier series? Now, this Fourier series on what? Signals. Look at everything we are discussing with respect to signals domain. Now first, students have to know that what is the purpose of studying this Fourier series? Why should you study Fourier series? Because in mathematics, any signal, you take any signal that is x of t, they can be expressed in terms of trigonometric functions. You take any signal or any function. You take any function, for example, look at x. X is general variable or t is general variable. Now, this can be expressed in terms of trigonometric functions. This can be expressed in terms of trigonometric functions. Actually, x doesn't contain either sine or cos. T doesn't contain either sine t or cos t like that. But by applying Fourier series, you can express x in terms of trigonometric series. You can express t in terms of trigonometric series. That is the important of Fourier series. So before that one, students have to understand first the purpose of studying Fourier series on signals. The purpose is that any signal can be expressed in terms of trigonometric terms. Trigonometric terms means what? All are periodic. Again, you may have wondered, why should I convert these into trigonometric? What is the necessity or necessary? Because why you are converting into trigonometry? Because all sine, cosine are periodic. All sine, cosine are periodic signals. These are all are periodic signals. So because of its periodicity, now, so all these are periodic signals. Now just look at, students again observe that the purpose of converting a non-trigonometric signal into a trigonometric signal is we are converting into either sine or cosine terms. Then we know that all sine, cosine are periodic signals. That means then all properties can be applied on this one. The time shifting, time inversion, time scaling, everything, all properties can be applied on this one. So the main purpose of studying Fourier series is to convert a non-periodic signal into a periodic signal. So now students have to convert like this. This is a non-periodic signal. A non-periodic signal. Now, this non-periodic signal is converted into a periodic signal. Non-periodic signal is converted into periodic signal by using what? Fourier series. By using the Fourier series. Very, very important transformation and technique in engineering, Fourier series. Students have to have online experience of calculations of this Fourier series. Now this is very much important. Now just look at, we started a Fourier series concept on signals. The main purpose is that every non-trigonometric signal can be converted into trigonometric signal. What is the purpose of trigonometric signal? Because the sine and cosine are here the trigonometric signals. These are periodic signals. Periodic. That means periodic signals. One more point. What is the purpose of discussing these periodic signals? That means Fourier series can be applied only on periodic functions, only applied on periodic signals or periodic functions. They can be only applied on periodic signals or periodic functions. Make it a point. So to apply a Fourier series concept, the given signal or function should be in periodicity, otherwise you can't apply. There is the most important concept of periodic signal. Now here you take any signal, x of t. X of t can be written as a naught plus summation 1 to infinity an cos n omega naught t plus bn sin n omega naught t. This is the main concept of Fourier series. Now just look at x of t. Does it contain any sine or cosine? No. But after application of Fourier series, now this is a sum individual harmonic, leave it. It can be converted into either cos terms and sine terms. That is the most important concept of this Fourier series. Now, Fourier series. One more point, Fourier series can be applied only on periodic signals. Okay? Thank you.